2.6, Finding Rational Zeros. In previous sections, we've been looking for zeros of a polynomial function by having the textbook or the question give you one of the zero as a hint for you to use synthetic division in order to find the other zeros. In 2.6, we're not going to be given one to begin with. However, we're going to use the rational zero theorem to find additional ones. The way we're going to do that is using this theorem that says if there are any rational zeros of a polynomial function, those rational zero will always follow these two forms, this form, where the number on the top will be one of the factor of the constant term, that's the last number, and the bottom would be a factor of the leading coefficient. That sounds very abstract, but when we do it for real, you'll see that it's actually pretty straightforward. What this is saying is that if this polynomial function has a rational zero, then the zero will look like this. You will have p over q, where p could be factors of 12, which are 1, 2, 3, 4, 6, and 12. And q will have to be factor of 1, which is simply 1. Which means 1 over 1 is 1, 2 over 1 is 2, 3 over 1 is 3, and so on. So again, what this means is that if this polynomial function have any zeros that are rational, so this doesn't include irrational or imaginary zeros, but if you have any rational zeros, you will have to come out of this list. So in this example, it's a little more complicated because you have a composite number in the back and a composite number in the front. So when you write p and q, the p can now be 1, 2, 5, 10, and the bottom can also be 1, 2, and 4 because the number 4 has 3 factors. So now the combination is a little bit crazy. Let's deal with 1 first. So you're going to have 1 over 1, 2 over 1, 5 over 1, 10 over 1. So it's positive negative 1, positive negative 2, positive negative 5, positive negative 10. And then we can deal with the 2. That's positive negative 1 half, that's 1 half. Positive negative 2 over 2, which is same as 1, so I'm not going to write that again. Positive negative 5 over 2, and positive negative 10 over 2, which is same as 5, so we'll skip that as well. And then we can deal with the 4, so that's positive negative 1/4. That's also 1 half, which we already have, so we're going to ignore that. Positive negative 5/4, and positive negative 10/4. However, 10/4 simplifies to 5 half, which we already have, so we're going to ignore that one. So again, if this polynomial function has any rational zeros, then it would come out of one of these 16 possible rational zeros. Again, I emphasize the word possible because not all 16 of them are going to be zeros for this function. So let's look at an example where we find the actual zero of this function. So first of all, we have to list the possible ones since the book doesn't give you a zero to begin with. So the possible ones of rational zero of this function would be factor of 20, which is 1, 2, 4, 5, 10, and 20, over the factor of 1, which is just 1. So I have to check positive negative 1, positive negative 2, positive negative 4, positive negative 5, positive negative 10, and positive negative 20. These are all the possible rational zero I have to try. So for the sake of keeping things simple, we're going to use synthetic substitution. But to keep things simple, you want to try numbers that are easy to do, or after you do it a couple of times, you get a feel of what number might work or might not work. But in this case, I'm just going to try the number 1. So do 1 times 1 is 1, negative 7 times 1, negative 7, 4, 4, 24. So that doesn't work. So 1, positive 1, is not an actual real zero. So let's keep going. Let's try a different number. In this case, let's try 1, negative 8, 11, 20. Let's try the number negative 1. Put 1 here, negative 1, negative 9, positive 9, positive 20, negative 20, and 0. So that 0 is good, which means negative 1 is one of my 0. So this becomes a similar question to 2.5, where you now have one of the zeros, and what's simplified here is becomes now x squared minus 9x plus 20, which is something you can now factor easily using FOIL, which give you the other 2, which is 4, positive 5. And I'm going to write this one down as well, negative 1. Okay, so let's take a look at the whole problem. The original function is x cubed minus 8x squared plus 11x plus 20. The book doesn't give us one of the 0, so we have to list the possible ones first, and then pretty much do like a guess and check. Once we do the guess and check and get one of them, we don't want to use a possible 0 anymore because that's too slow. We use FOIL to get to the other 2 factor, which give us all 3 of them at the end. Unfortunately, these kind of problems can get very nasty when the leading coefficient is not 1. For example, in this polynomial function, the number of possible rational zeros are many. In this case, we have to list all the factors of 12 on the top, which is 1, 2, 3, 4, 6, 6 and 12. And this could be over all the factors of 10, which is 1, 2, 5, and 10. So without wasting your time, let me list the possible zeros on the side. And you can see that it's almost going to be very painful to want to try all these zeros. So instead of going at it randomly, usually when the coefficient is not 1, which makes the problem a little bit harder, this 10 makes the problem a little bit harder, the test or the textbook homework question will provide you a graph like this, so that you can take a look at the 0. Again, zeros are the same as the x-intercept. So if they tell you that this is a graph of the function, we can kind of estimate that this point looks like it would be something like a negative 3 over 2, which is one of our possible functions. So let's go ahead and try it. So 10, negative 11, negative 42, 7, 12, and we're going to try negative 3 half. And fast forward a little bit, you see that negative 2/3 actually doesn't work. So even using the graph, we might still make a bad guess. Let's try a different one. This one looks like it would be negative half, and negative half is one of our possible functions. So this I'm going to do negative half on the side. And we're going to do synthetic division. And again, fast forward a little bit, we get a 0. So negative half is one of the zeros. So this is taking advantage of the graph to get to one of the zeros that we need. Now, we're not even done yet, because the result of this synthetic division doesn't actually give us a quadratic function. So we still can just simply use FOIL to factor this. Again, this looks like this: x cubed minus 16x squared minus 34x plus 24. So we're still at a point where we have to use possible rational zeros in order to keep going at this. So again, I'm going to list the possible rational zero for this function. Before I do, though, I've noticed that all these numbers are divisible by 2. So I'm going to go ahead and take 2 out of this factor. So 5x cubed minus 8x squared minus 17x plus 12. So the possible factor that I have to work with in this case becomes factors of 12. So 1, 2, 3, 4, 6, 12 over 1 and 5. So again, I have to list all of them. And again, this is not something we probably want to do just using guess and check. So I'm going to come back to this chart over here. I'm going to pick a number that seems to might work. Let's go ahead and try this number here. That one is either around 1/2 or somewhere around 1/2. However, 1/2 isn't on this list. The closest thing to 1/2 is this 3/5. So I'm going to use 3/5 for my synthesis division. I'm going to list these coefficients here: 5, -8, -17, and 12. And that worked out perfectly. So 3/5 is another 0 of this polynomial. And this leaves us with a quadratic function, 5x squared minus 5x minus 20. Let's go ahead and take the 5 out. I have x squared minus x minus 4. Unfortunately, this quadratic function cannot be factored by using FOIL. So we actually need to use the quadratic formula. So -b plus minus b squared minus 4ac over 2a, which is equal to 1 plus minus square root of 17 over 2. So zoom out a little bit, see the whole problem. Let's list all the 0 that we have found. So the 0 we found is -1/2, 3/5, and 1 plus minus square root of 17 over 2. So let us recap the 3 major kind of main steps that we did to find the zeros of this polynomial function. The first thing is using the rational zero theorem to find the first rational zero using factors of 12 over the factors of 10. And once we find one factor, we're able to simplify the fourth degree polynomial into a third degree. And we use the rational zero theorem again to find another zero and simplify the function into a second degree quadratic function, which then we use the quadratic formula to find the last two. And this is as hard as it gets for this section. Not all your questions are going to be this complicated. But before we move on, let's just look at this word problem really quickly. We're not going to do the full problem because I'm sure you have already heard enough from this video. But in this situation, they're just giving you a volume, and the volume that needs to be basically just a formula. And you're going to be working with volume so that you're ending up with the equation that have at least a third degree. So that when you write it into standard form, set it equal to 0, you're going to end up with a polynomial function that you will have to use the rational zero theorem in order to find your zero. So you have to test these, see which one actually works, and then you can solve for your x. So hope that works. Hope that help you understand the concept in this section. Feel free to watch some parts over again, and I would definitely answer more questions when we look at this together in class next time. Thanks for watching.